Hello, my name is Brian Ortiz, and this is my poster presentation. So we're trying to find out if basically does the chronic antiviral response to double-stranded RNA formed as a result of ADAR1 laws require LGP2 coactivation. So to give out a background information, ADAR1 is an enzyme that edits double-stranded RNA, and MDA5 and LGP2 are both RLRs receptors that recognize double-stranded RNA and help activate the antiviral response into response to that. The reason why they activate this response is because a lot of times double-stranded RNA are viruses and they try to come inside our body, and these receptors help protect our body from further damage. So we have three receptors in the RLRs group. It's LGB2, MD5, and then the RIG-I. The LGB2 is a little bit different from RIG-I and MDA5 because LGB2 does not have this CAR domain. So if you look on the left of the picture, on the left top, the corner left, you can see that the yellow part is the CAR domain and how that RIG-I and MDA5 have this CAR domain and then LGB2 does not. On the right side of the image B, you could see that how RIG-I and MD5 use the CAR domain to activate MAVs and then lead to antiviral response. Basically, they facilitate the response. LGP2 is a little bit different from RIG-I and MD5 because of this, and it has its own function of regulating both MD5 and RIG-I. It does this by it can inhibit RIG-I and also help facilitate the MD5 formation. So ADAR1 is an enzyme that edits double-stranded RNA, as I said before, so it's not read by MD5. So when ADAR1, the specific isoform we're looking at is P150 of the ADAR1, and when it edits the double-stranded RNA, MD5 does not recognize it, and it would not lead to the antiviral response. So when we look at the mice that had ADAR1 knockout, it only makes sense that the MD5 was constantly being activated because of the receptors, and it was constantly recognizing double-stranded RNA, and it led to the immediate death of these mice because it was constant activation of antiviral response because these double-stranded RNAs were being recognized by MD5 when they needed ADAR1 to edit it. So also we want to find out if there's a role of LGB2 and MD5 recognition of these indigenous RNA that arise in the presence of ADAR1 is unknown. So to talk more about LGB2 coactivation of MD5, we know that that LGB2 coactivation of MD5 leads to smaller and short formations of peptides, and these peptides, since they're smaller, they can produce LGB2 can help facilitate more than without it, and then MD5 without LGB2 will need to form longer and less amounts of these filaments. And basically, when there's short formations of MD5, they won't facilitate MAZ activation because without LGB2 it won't happen, and there's nothing facilitating it. They will need longer peptides to produce a MAZ activation. And to further explain this, the LGB2 coactivation, the short peptides that are formed produce stronger signaling compared to the longer ones. So LGB2 overall helps benefit MD5 activation. So the way we can understand if LGB2 is required for MD5 recognition of RNA that are not edited by ADAR1, we need to look at the different mice. So when we look at the different mice, we see that we have to take the P150 head and the LGB2 head and crossbreed them with the female version, and then check the fetuses to see how much of them survived. So basically, we were right. 11% would survive, and the main point of this is to find out if the mice with the LGB2 ended up going up and surviving with the LGP2 knockout, basically those mice, basically they prove that LGP2 activation is necessary in recognizing these RNAs that are not edited by ADAR1. Because if you think about it, LGB2 coactivation is needed for the short formation of peptides. So if these might survive, that means that the short formation of peptides were being formed due to the ADAR1 loss. And when we look at the other mice, say they didn't survive, they didn't survive the LGB2 knockout. That means that the only other way would be from NDA5 activation without LGB2, because that means there would be longer formations that were of there would be longer formations of peptides, and that means that LGB2 did not play a role. So that's the way we could find out if they just basically on their survival, and understanding if LGB2 is needed will give us a better sense of the size and identity of the RNA that triggers chronic interferon production when ADAR1 editing is lost.